Question 1. Write 30 to 12 in the form n to 1. So I'm just going to rewrite this slightly because I want to see which part of the ratio that n relates to. So n means this side of the ratio can become any value, but this side needs to become 1. So to get from 12 to 1, I need to divide by 12. So to get from 30 to whatever goes here, I also have to divide by 12. 30 divided by 12 is 5/2. This is the only instance when you can have a decimal or a fraction value inside a ratio when you're simplifying to this form. So that missing value there is 5/2. It doesn't state whether it wants it as a fraction or a decimal, so we're good to go with that. Question 2. 4 consecutive triangular numbers are 6, 10, 15 and 21. Write down the next triangular number. So let's treat this like a normal sequence. So from 6 to 10 we add 4, 10 to 15 we add 5, 15 to 21 we add 6. So it stands to reason that the next number we would add is 7. 21 plus 7 is 28. So 28 is the next triangular number. Question 3. Write down the reciprocal of 4/7. So the reciprocal of a number is what you would multiply that number by to get 1. In this instance, we're dealing with a fraction, so it's simply a case of flipping that fraction upside down to find the reciprocal. If I had a decimal, I'd change that decimal into a fraction, and then I would flip it upside down. Question 4. The price of a toy increases by 12.5% to £19.53. Work out the original price of the toy. So if I've increased by 12.5%, that's 100 plus 12.5, so that's 112.5% in total. So this £19.53, using a proportion table, I use these quite often, you'll know from my other videos, that £19.53 is 112.5%. So that's our percent and that's our pounds. If we want to find the original price of the toy, we want to find what it was at 100% before we added the 12.5% on. So the first thing I'm going to do is I'm going to take this down to 1%. So to go to 1%, I'm going to divide by 112.5. And I have to do the same on the other side. So 19.53 divided by 112.5, which is 0.1736. I'm aiming for the original. I'm aiming for 100%. So to go to 100%, I would then multiply the 1% by 100. So then let's do the same on the other side. Multiply by 100. That gives me 17.36. We're dealing with money, so we need it to be in 2 decimal places, so it's worth double checking that at this point. So the original price of the toy before the increase was £17.36. Question 5. Jess saves 2p, 5p and 10p coins. She has 45 10p coins, 8 times as many 2p coins as 10p coins, and then £17.70 in total. So they want us to work out the total value of 2p coins to the total value of 5p coins, giving our answer in its simplest form. Okay, so first of all, we have 45 lots of 10p coins. So 45 times 10 is 450p, which is £4.50. There are 8 times as many 2p coins as 10p coins. So if we've got 45 10p coins, we've got 8 times 45 2p coins. So 8 times 45 times the 2p is 720p, which is £7.20. So that's the total of 10p coins. This is the total of 2p coins. Now we want to find the total of 5p coins because it's the totals that we need inside this ratio for our answer. So the first thing I'm going to do is I'm going to add the two values together that we know. So £4.50 plus £7.20, which is £11.70. There's £17.70 in total. So I'm going to take that £11.70 away. And that tells me that there's £6 left. So that £6 must be the total of the 5p coins. So now we have to write our final ratio. So they want the total value of the 2p coins to the total value of the 5p coins, but we have to do it in our simplest form. So let's write the values we have now. So total of 2p to the total of 5p. So the total of 2p was £7.20. Total of 5p was £6. Now we need to get it into our simplest form. So what I'm going to do is I'm going to divide them both by 2. That gets us to 3. 3.6. Now I'm going to divide them both by 0.3 because I know that 0.3 goes into each of these. So 3.6 divided by 0.3, 12. 3 divided by 0.3 is 10, because then it's going to make my life a little bit easier to simplify. So now I can half both of these and gets to 6 to 5. 6 and 5 don't have a common factor other than 1 at this stage. So that's our simplified ratio. Question 6a. Part of a regular polygon is shown. Assume that the polygon is an octagon. Okay, so that's 8 sides. Work out the size of an exterior angle. So there are 8 exterior angles. So we've got 8 sides, 8 exterior angles. It's a regular polygon, so I'm expecting all those angles to be the same. Now, the sum of exterior angles is 360 degrees. So if I do 360 divided by the number of sides, that tells me that each of those exterior angles should be 45 degrees. I'm going to pop that on my answer line. 6b. In fact, the polygon has more sides than an octagon. What does this mean about the size of an exterior angle? And we've got to tick one of these boxes. So it's either going to be more than that answer, the same as this answer, less than, or it could be any of the above. So let's think about this. To find the exterior angle, we divide it by the number of sides. So here we divided by 8 to get 45. If the polygon has more sides than an octagon, then we're going to be dividing by a bigger number. If we divide by a bigger number, we're going to get a smaller answer. So we're going to tick that box there because it would be less than the answer to part A. Question 7. In a game, an ordinary fair 6-sided dice is rolled. The fair spinner shown is spun. The score is the dice number substituted into the spinner expression. Complete the table below to show all of the possible scores. So we've got 2x, 3x and x squared, and they're here in this table for us, and we are substituting. So these are the values that we substitute. These are the values on the dice. So if we roll a 1 on the dice, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, this one's already completed, 2 times 5 is 10, and 2 times 6 is 12. 3x means 3 times x, so 3 times 1, already completed, 3 times 3, 3 times 4, 3 times 5, and 3 times 6. X squared, we multiplied the number by itself. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is already done, 6 squared is 36. Part B, a player wins the game if their score is 10 or more. Work out the probability that they will win the game. So we're going to have a fraction here as our probability. So they win if they score 10 or more. So let's have a look at this table. 1, 2, 3, 4, 5, 6, 7, 8 scores are 10 or more. So that's the numerator for our probability fraction. Our denominator is the total number of scores. So 3, 6, 9, 12, 15, 18. So we're going to put 18 on the bottom. It doesn't say that we have to simplify it, so I'm just going to write 8 over 18 on my answer line. Okay, the game is played 711 times. Estimate the number of games that are won. So we know the probability of winning is 8 over 18. And then if we multiply that by the number of times the game has been played, that should tell us how many games we would expect to win. 316. Question 8. We have this identity here because we've got the 3 lines in the middle. That means the left-hand side is identical to the right-hand side. Work out the values of A and B. So the first thing I'm going to do is I'm going to expand and simplify the left-hand side just to make my life a little bit easier. So A multiplied by x squared is ax squared. Negative 3 multiplied by x squared is negative 3x squared. And then I've still got the plus 2b. I've not done anything with that. And that's identical to 5x add 12. Now, I'm just going to factorise these x squared terms. And then I can make some comparisons here. So, the a subtract 3 must be equivalent to the 5. And the 2b must be equivalent to the positive 12. So we can use this information to find the values of a and b. So a subtract 3 equals 5. So a equals 5 plus 3, which is 8. 2b equals 12. So b equals 12 divided by 2, which is 6. Question 9. A has coordinate 1, 3 and B 2, 9. These are points on a centimetre grid. They're marked there for us. ABCD is a parallelogram. AD and BC are horizontal and each has a length of 5 centimetres. The diagonals of ABCD cross at E. Work out the 2 possible pairs of coordinates for E. So for this one, we want to be drawing ourselves that parallelogram that's formed by A, B, C and D. Now what it tells us is AD and BC are horizontal and their length 5 centimetres. So let's imagine that the point D is to the left of A. So we've got 1, 2, 3, 4, 5. So we're going to imagine that point D is here. And then point C would be 5 to the left of B. 1, 2, 3, 4, 5. So that's point C. And then E is where the diagonals intersect. So this would be one option for E. So let's read that coordinate off first. So it's -1, 6. However, C and D could also lie to the right-hand side of A and B. So let's do the opposite on the other side. So C will be 5 to the right. 1, 2, 3, 4, 5. So that would be C. D would be 5 to the right. 1, 2, 3, 4, 5. So then we would have a parallelogram here. And then if we draw the diagonals, it gives us another possible coordinate for E. So that's 4, 6. Question 10. Write down the translation vector that maps shape A onto shape B. So the translation vector is just a column vector. So we're going to have these tall brackets that tells us how many places shape A has moved to the left or right and up or down. So we're just going to pick one corresponding corner. So this corner of A corresponds to the corner of B. We're mapping shape A onto shape B, so we're starting at shape A. That's important when we're finding vectors for translations. So we're just going to see how far we've travelled, and we only go to the point where these two lines intersect. So we've gone 1, 2, 3, 4 to the right, and then 1, 2, 3 down. So to fill out this vector, 4 to the right, the top part of the vector is left or right, and it's positive if we go right. Then we've gone 3 down. The bottom part of the vector is up and down, and it's negative when we go down. Question 11. We've been given the formula for the volume of a sphere. A bowl is a hemisphere with radius 12 centimetres, so a hemisphere is half of a sphere. So let's put that there to remind ourselves. Water is poured into the bowl at a rate of 325 centimetres cubed per second for 8 seconds. Does the water fill more than 70% of the bowl? You must show you're working out. So first of all, let's find out how much water this bowl could hold. So we're going to find the volume of this hemisphere. So we're going to use the volume of a sphere, but then because a hemisphere is half of a sphere, we will divide our answer by 2. So let's substitute in what we know. We're given the radius as 12, so we've got 4/3 times pi times r, the radius of 12 cubed, and then once we've got that, we'll divide our answer by 2. So let's stick that into our calculator. 4/3 times I lost my pi button then. Times pi times 12 cubed, and then we're going to divide it by 2. So we have 1152 pi. I'm going to leave it in terms of pi in exact form because I don't want to mess around with a load of decimals at this point. This just makes my life a lot easier. So that is the total the bowl can hold. Okay, and we're in centimetres cubed. If water's poured into the bowl at a rate of 325 centimetres cubed per second for 8 seconds, let's find out how much water's been poured in. So 325 times 8. So 2,600 centimetres cubed of water is going into the bowl. So now we're going to find out if that's more than 70%. So the total amount of water that the bowl can hold is 1,152 pi. The actual amount that's going into the bowl is 2,600 centimetres squared. And if we multiply that by 100, that will give us a percentage. So, see, that was why it was miles easier to not write that as a decimal at that point. And then times it by 100. So we have 71.84%. Let's go back to the question. Does the water fill more than 70% of the bowl? 71.84 is greater than 70%. So let's put nice and clearly, yes. Question 12. Show that these two rectangles are similar. So we've got this rectangle that's smaller with a length of 12 and a width of 5. This rectangle that's bigger with a width of 8 and a length of 19.2. So for shapes to be similar, they have to have a common scale factor. And that scale factor has to be the same for all of the sides of the shape. So let's find the scale factor that links the sides of these shapes that correspond. So we're going to find the scale factor for the two widths to start off with. So we're going to do 8 divided by 5. Which is 1.6. So that's the scale factor for the width. So let's find the length scale factor. So we're doing 19.2 divided by 12. That's 1.6. So 1.6 and 1.6, they have the same scale factor, so they are similar. So let's just play it safe. Same scale factor means similar. We've shown it, but it's worthwhile just making a little statement to make it nice and clear. Question 13. A factory packs X boxes of tea bags per hour. Each box contains 80 tea bags. Show that the factory packs 4x over 3 tea bags per minute. Okay, so X boxes in an hour, and each box contains 80 tea bags. So 80x will tell us the number of tea bags in total for 1 hour. We're dealing with minutes here though. So 80x would give us 60 minutes. Again, a proportion table just to organise myself. So there's 80x tea bags in 60 minutes. We want 1 minute. So we're going to divide by 60. So we've got 80x over 60 at this point. So this gives us the number of tea bags per minute. So let's simplify this expression. So we've got 80x over 60, which is 8x over 6. Now a little trick here. If you put 8 over 6 as a fraction in your calculator, it will simplify it for you, which is 4 over 3. And obviously we've still got the x there. So we've shown that they pack 4x over 3 tea bags every minute. Question 14. A company has 123 employees. Information about their hourly rates of pay is shown in the table here. The owner of the company uses the data to make two statements. Statement A. Over 30% of employees have an hourly rate that is more than £17. Statement B. The average hourly rate of pay is more than £20. 14A. Show working that supports statement A. So we're looking at employees that have an hourly rate of more than £17. So £17 is going to fall within this range between 14 and 20. Now 17 is the midpoint between 14 and 20. So we can assume at this stage that half of these earn £17 or more, and then this 15 and this 10 also. So 16 plus 15 plus 10 is 41 people in total potentially earning £17 or more. Let's see how that compares to 30%. So we've got 41 out of 123 in total, and then if we multiply it by 100, that will give us our percentage. So 41 out of 123. So that's 33.3 recurring percent. So we've shown working out that supports statement A, saying that over 30% of employees have an hourly rate that's more than £17. 14B. Why might statement A not be true? Well, it might not be true because yes, 17 is the midpoint between 14 and 20. However, we don't know what the distribution of wages is within those 32 people. So what we have to say there is we don't know the distribution within the interval and that's the 14 to 20 interval. So it's as simple as that. We assumed that with it being the midpoint, it was half, but we don't know that exactly because we don't have all of the data. Okay, work out an estimate of the mean to support statement B. So we're going to have to go back to our table here and use this information too. So to find an estimate of the mean, we need the midpoints of all of these ranges to start off with. So the midpoint of 10 to 14 is 12, 20 to 30 is 30, 40 to 100 is 70. If you're not sure, 40 plus 100, 140 divided by 2 is 70. And then what we're going to do is we're going to times these values by the number of employees. So we're going to have 12 times 66, 17 times 32. We can do this because it's an estimate. 30 times 15, and then 70 times 10. So let's do that to start off with. 12 times 66. 17 times 32. 30 times 15. And then 70 times 10. So let's find the total of those. So 792 plus 544 plus 450 plus 700 is 2,486. Now we're going to divide that by the total number of people, which we know is 123. So that tells us it's 20.21. Okay, so let's remind ourselves of statement B. The average hourly rate of pay is more than £20. We've just worked out that the average hourly rate of pay is £20.21. £20.21 is more than £20. Okay, 14D. Why is the mean not the best average to represent the data? So this is simply because it can be affected by outlier or extreme data values. So it can be affected by outliers, extremes. Okay, because it includes all of the data, doesn't it? We can't see it visibly. Question 15. Expand these two brackets. The first bracket is x squared subtract 9xy. The second bracket is 2x add 5y. So when we expand, we multiply everything in one bracket by everything inside the other. So let's start with this. X squared times 2x is 2x cubed. X squared times positive 5y is positive 5x squared y. Negative 9xy multiplied by 2x is negative 18x squared y. Negative 9xy multiplied by positive 5y is negative 45x y squared. So now we need to see if we have any terms that are like terms so that we can collect them together and simplify. We've only got the 1x cubed term, so that's going to stay as it is. We've got x squared y, and we've also got x squared y here. So these are like terms. This one isn't, because the x isn't squared, the y is. So these two here can be combined as they are like terms. So we are starting with positive 5 and subtracting 18. You've got a calculator, so if negative numbers fuzz your brain a little bit, pop it in your calculator. Negative 13 x squared y, and then we've still got the negative 45xy squared because there were no other terms to combine it with. Now I'm happy with this. I'm going to pop it on my answer line. Question 16. Line A has equation y equals ax subtract 1. And it passes through the point 7, 13. Line B has the equation 5y subtract 3x equals 4. Show that the line A has a greater gradient than the line B. So let's focus on line A to start off with. So the equation of a straight line is y equals mx plus c, and the m is what tells us the gradient. In this question, the m is a, so we don't know the gradient of line A to directly compare it, so we're going to have to figure out what that value is. It gives us a coordinate that it passes through. Remember, coordinates are x and y coordinates. So I'm going to substitute this x and this y value into line A's equation. So y equals ax subtract 1. Well, y equals 13. X equals 7, so that's 7a subtract 1. Now I'm going to solve this for a. So I'm going to add 1. And then I'm going to divide by that 7. So a equals 2. So line A has the equation y equals 2x subtract 1, which tells me that the gradient of line A is positive 2. Okay, now we need to find the gradient of line B. So we're given 5y subtract 3x equals 4, but it isn't really in this form. So I'm going to rearrange this equation. So I'm going to add 3x to both sides, because then this moves my 3x over to this side. So I'll just rewrite that slightly just to make it a little bit more sense. So now we've got our mx plus c. The problem here though is it's 5y, not y. So what we're going to have to do is divide by that 5. So divide by 5, y equals 3 over 5x, add 4 over 5. So the gradient of line B is 3 over 5. So 3 over 5 is less than 2. So line A has a greater gradient. Question 17. So we've got a triangle formed by two right-angled triangles. Work out the size of angle x. So this is angle x, and when I'm dealing with right-angled triangles, I'm either going to use Pythagoras or trigonometry. To find the angle x, I'm going to have to use trigonometry, but to do that, I need the value of 2 of the sides. So I'm going to have to either find BC or AC. Now, currently, I have no information that's going to help me find BC whatsoever, but I do have this triangle here, the hypotenuse and another angle, so I could find AC. So let's start by finding AC. So we're going to ignore this triangle to start off with. So the 4 is the hypotenuse. This must be the opposite because it's opposite the angle, which tells us that AC is the adjacent. So if I'm finding the adjacent, this is the one I'm finding, this is the one that I know. So adjacent and a hypotenuse, I'm going to be using this trigonometric ratio. The C stands for cos. So cos 37, because that's the angle we're given, equals the adjacent divided by the hypotenuse. So let's substitute in what we know. The adjacent is what we're looking for, it's AC. And the hypotenuse is 4. Now, because I'm looking for the adjacent, if I cover that up in my triangle, I'm doing cos multiplied by the hypotenuse. So AC is equal to cos 37 multiplied by that 4, which is 3.19454,204. So now I know what AC is. I'm going to ignore this smaller triangle, work with this bigger triangle, and I'm going to then attempt to find the angle X. So let's start labelling the sides now on this bigger triangle here. So we're ignoring that smaller one, we're just working with this triangle now. If it makes life easier for you, grab yourself a sheet of paper, cover that information up so you don't get confused, okay? You can ask for scrap paper in your exams, that's not a problem. You just can't submit it as part of your exam paper. So let's relabel this triangle. Opposite the right angle is the hypotenuse. Opposite the other angle, whether we know what it is or not, is the opposite, which means this side BC must be the adjacent. So we want to find the angle. So we know what the hypotenuse is, and we've just worked out AC, so we know what the opposite side is. So we're now dealing with this ratio triangle. S stands for sin, so sin x equals the opposite over the hypotenuse. The opposite we've worked out up here. So sin x equals 3.19454,204, and the hypotenuse we know is 9.3. The issue is here we're finding x. So we're going to have to do the inverse sin of all of this. So 3.19454,204 over 9.3. So that's what we're going to stick in our calculator. So to find the inverse sin function, you press shift and the sin button. Same for if you were working with cos or tan. So let's put a fraction in there. 3.19454,204. 9.3. Arrow away from the fraction. Close your brackets and press equals. So we have 20.09020484 degrees for that angle. Now if we go back to this question at the top here, guys, it doesn't say what to round the angle to. Usually we work to 1 decimal place for angles, so let's do that here. I've written the full thing just to be safe, but to 1 decimal place that's 20.1. So I'm going to write 20.1 to 1 decimal place on my answer line. Question 18. Rearrange y equals x add 8 divided by x to make x the subject. So the first thing I'm going to do is I'm going to get rid of this fraction. So I'm going to multiply both sides by x. So the left hand side becomes yx, and then the right hand side becomes x add 8. I've eliminated that fraction. Now what we notice is we've got the letter x that we want to make the subject in this equation twice. So I want to make sure that all terms with an x in are on the same side of the equation. So let's move them so that they're all on the left hand side of the equation. So instead of having positive x here, I'm going to subtract x from this side, which leaves 8. And then when I subtract x from this side, I have yx subtract x. Now I'm going to factorise the left-hand side because I only want one version of the x. So if I pull out a common factor of x, y times x becomes y, and the negative x becomes negative 1. Now that I've factorised and got the x in 1, I'm going to divide by that bracket. So x equals 8 over y subtract 1. It's important when you're dividing that the whole thing goes underneath and we write it as a fraction. And then I'm going to pop that on my answer line. So x equals 8 over y subtract 1. Question 19. Here are the first 4 terms of a quadratic sequence. So knowing that it's a quadratic sequence is important. 3, 20, 47 and 84. Work out an expression for the nth term of the sequence. So, first of all, let's find the difference between the terms. So to get from 3 to 20, we add 17. 20 to 47, we add 27. And then that's gone up by 10. And now it's a quadratic sequence. I'm expecting them to go up, the differences to have the same difference between them, if that makes sense. So 84 subtract 47, I'm expecting 37. Yeah, that's right. So add 37. So that's our first difference. So then we work out the second difference, the difference of the differences. So from 17 to 27, add 10. 27 to 37, add 10. So that second difference here is important. Half of that gives us our A term. So A is 10 divided by 2, which is 5. So that tells us we have 5n squareds in our nth term for this quadratic sequence. So now what we're going to do is we're going to generate the sequence for 5n squared. Now, let's use n values. So we've got first term, second term, third term, fourth term. So first, second, third, fourth. Remember, you've got a calculator that you can use at all points throughout this. So 5n squared, if n is 1, 1 squared is 1, times by 5 is 5. If n is 2, 2 squared is 4, times by 5 is 20. If n is 3, 3 squared is 9, times by 5 is 45. And then 4 squared is 16, times by 5 is 80. So what I'm going to do is I'm going to write this sequence underneath here now. So we've got 3, 20, 47 and 84. And I'm going to compare what happens to get from here to here. So from 5 to 3, subtract 2. 20 to 20, nothing. 45 to 47, we've added 2, and then 80 to 84, we've added 4. So now what we're going to do is we're going to find the linear nth term for the differences between 5n squared and the sequence that we're trying to find the nth term rule for. So from negative 2 to 0, we add 2. From 0 to 2, we add 2. And then from 2 to 4, we add 2. So it's 2n, and then to get from 2 to minus 2, we would subtract 4. So we have 5n squared plus 2n, subtract 4. So both parts of this go together. Let's just double check though, before we stick that on our answer line. So for the first term, it's 3. So when n equals 1, that first term, 5 is 1 squared. So that's what we're going to work out here. And what we're expecting is an answer of 3 if our nth term is correct. So 1 squared is 1, times by 5 is 5. 2 times 1, subtract 4. Okay, 5 plus 2 is 7. 7 subtract 4 is 3, which matches the first term in our sequence. So we can confidently write this nth term rule on our answer line. (20a) P, Q and R are points on a circle. S is a point inside triangle PQR. So P, Q and R are points on a circle. S is that point there inside this triangle. Assume that S is the centre of the circle. Work out the size of the angle X. So this is circle theorems. If S is the centre of the circle, then the angle at the circumference X should be half of this angle at the centre. So 130 divided by 2 is 65 degrees. So we can, assuming that S is the centre, say that X is 65 degrees. 20b. In fact, the centre of the circle is on PS. So somewhere here, but not at S. What does this mean about the size of angle X? So is it the same? Is it greater than, smaller than, or is it impossible to tell? Well, it's impossible to tell because we don't know where it's going to be on this line PS. It could be anywhere, couldn't it? So it's impossible to tell at this stage. 20c. For a different circle, AB is a tangent at A. C and D are on the circumference of the circle, and AC is equal to CD. Here is Simon's method to work out the size of angle Y. He says that angle ADC equals 70 degrees for the alternate segment theorem. Therefore, Y equals 70 degrees because of angles in an isosceles triangle. Is he correct? And give a reason for your answer. Okay, so he's used the alternate segment theorem here. He's not correct because it's not the angle ADC that would be 70. It's the angle ECD here that would be 70 by that rule. So, no, he's not correct. It's ACD that equals 70 degrees, not ADC. Question 21. Morgana decides to put £500 into an account that pays compound interest. She wants to have at least £560 in the account after 3 years. Work out to one decimal place the minimum annual interest rate that she needs. So if we knew the interest rate, what we would do would be the amount multiplied by the interest rate to the power of 3. And what we'd be wanting is that this value would be at least £560. So greater than or equal to £560. But we don't know what this interest rate is. So let's call that X. And then we've got ourselves a bit of an inequality that we can have a go at solving. So 500 multiplied by x cubed. So remember, x is our interest multiplier. So we need to remember that. Is greater than or equal to 560. So let's divide both sides by 500. So x cubed is greater than or equal to 560 over 500. So let's work out what that is. 560 over 500. So x cubed is greater than or equal to 1.12. So let's figure out what x should be. So it's greater than or equal to the cube root of 1.12. Oh, wrong button. Which is 1.038498882. So remember, this is that multiplier. So the one part isn't included in the percentage interest. So actually the percentage interest is 3.849882%. We want it to one decimal place. One decimal place, so we could say that it's 3.8% to one decimal place. 22. An approximate value of a root of an equation x can be found using the iterative formula, and they've given that here for us. The starting value is x1, which is equal to 4. Part A, work out the values of x2 and x3. So the way an iterative formula works is you use the previous value to find the next value. So this would be xn, and then xn plus 1 would be x1 plus 1, which is x2. So to find the next value, we use the previous one. So we're going to use this iterative formula, but instead of xn, we're going to put the value for x1, because we're going to use x1 to find x2. So we have 5 times 4 squared, subtract 2 times 4, subtract 3. What you see here is what I'm going to enter into my calculator. Okay, so we have the cube root of 5 times 4 squared, subtract 2 times 4, subtract 3. And then I'm going to press equals. So x2 is 4.1015659.3. Now I'm going to go through and I'm going to use this value. So that's my answer. Okay. So let's change this. 4.1015659.3. 4.1015659.3. So x3 is 4.177641648. (22b) By continuing the iteration, show that the value of x is more than 4.25. Okay, so to continue it, we're going to find x4 x5, x6. Let's see what they give us. Now, to make our life easier, this answer that's stored, we're now going to go back to this, delete the previous answer that we put in. I'm going to press our answer button, and then it'll use the last answer that we generated, so we don't have to keep typing those values in. So if I press equals, so x to the power of 4 is 4.234116778. Press equals again, it's using the previous answer because I've used the answer button. So 4.275769448. Then again, 4.30634511. So what we're going to say here, we're going to stop here because it wants us to continue it to show that the value of x is more than 4.25. Well, it's already gone above 4.25 with the 5th and the 6th value here. So it's just going to keep going. And you can press your calculator to check. It will eventually show down, but they're all going to be bigger than 4.25. So we can stop at that point. Question 23. Here are 3 sets of cards. We've got set A, which is 8 cards, set B, 3, 6, 7 cards, set C, 4 cards. In a game, a player has 2 options. Option 1, pick 2 cards from set A. Option 2, pick 1 card from set B and 1 card from set C. The cards are picked at random. The player wins if the total of their 2 cards is exactly 10. Which option gives a better chance of winning? Option 1 or option 2? So we need to find the probability of winning in option 1, probability of winning in option 2, and then compare them. Okay, so if we're looking at option 1, if we want a total of 10, the only way we can make a total of 10 in option 1 is to do 5 plus 5. There are no other cards. If we added them together, we'd get an exact total of 10. So let's work out the probability of that happening. So if we pick out the first card that's a 5, we're picking out of 8 cards, and there are 1, 2, 3 possible options that we pick a 5. And then for the second card that we pick, because we're picking 2 cards from set A, there would only be 7 cards to pick from because we've already chosen 1, and that would leave 2 5s to pick from. So 3 times 2 is 6, 8 times 7 is 56. So we've got a 6 out of 56 chance. So option 1 is a 6 out of 56 chance of winning. Okay. Option 2 is that they pick 1 from set B and 1 from set C. So we need to figure out how many of those combinations would give us a total of exactly 10. So what I'm going to do for this is I'm going to sort it into a bit of a sample space diagram. So set C, so here we've got set C, and then here we'll have set B. So set C, the options are 3, 4, 5 and 6. I just find it easier to sort information into diagrams. And then for set B, we have 1, 2, 4, 6, 8, 8 and 9. So we can extend our lines there. Doesn't have to be perfect, it just has to organise the information for you. So when they pick each card, they total. So 1 plus 3, 1 plus 4, 1 plus 5, 1 plus 6, 2 plus 3, 5, 6, 7, 8. 4 plus 3 is 7, 8. 6 plus 3, 8 plus 3, 8 plus 3 again, and then 9 plus 3, and then we're adding all the others, but obviously we're spotting that they're going up in consecutive numbers. Exactly 10 then, so 1, 2. So out of all of those possible outcomes, there are 2 that give us a total of exactly 10. So for option 2, when we pick, we'll have 2 out of, so we've got 4, 8, 12, 16, 20, 24, 2 out of 28. Okay, Now what we need to do is compare these two values. So I've got a fraction out of 56 and a fraction out of 28. So what I'm going to do, so for option 1 is 6 out of 56. Option 2, if I multiply that fraction by 2, 28 times 2 is 56. So that would give me 4 over 56. So now they have a common denominator. I'm able to compare them. Okay, so which option gives a better chance of winning? Well, this is option 1 here, and this is option 2. Option 1, the denominator is the same, but the numerator is bigger. So option 1 is a greater probability than option 2. So we select option 1 out of the 2 boxes. Question 24. A equals 65 to the nearest integer. B equals 30 to one significant figure. Work out the upper bound for 2a squared subtract b squared. You must show you're working out. So straight away, they want us to work out the upper bound for this calculation. So I'm going to need the lower bound and the upper bound of these two values. So let's start with a. So the upper bound of a. So if we're rounding to the nearest integer, we're rounding to the nearest 1. Half of 1 is 0.5, so the upper bound would be 65 plus 0.5, and the lower bound would be 65 subtract 0.5. So we have 65.5 and 64.5. Let's do the same for b then. So we want the upper bound and we want the lower bound. So b is rounded to one significant figure. The first significant figure is the 3, which is in the tens column. Half of 10 is 5, so the upper bound we would add 5 and the lower bound we would subtract 5. So 35 and 25. Now we need to look at these calculations and figure out which value for A and which value for B we're going to use. So we want the upper bound, so we want the maximum answer for this calculation, the biggest answer we're going to get. So to get the biggest answer, we want to use our biggest number subtracting our smallest possible number. So if we want 2a squared to be our biggest number, we're going to have to use the upper bound of a to get the biggest number. So we're going to use a equals 65.5. And then to subtract the smallest possible number to get our maximum, our biggest answer, we're going to want to use the smallest possible value of b. So we're going to use the lower bound for b. So we're using a as 65.5 and b as 25. And then we're going to substitute these two values into this calculation. So we have 2 times a is 65.5 and it's squared, subtract 25 squared. So let's stick that in our calculator. 2 times 65.5 squared, subtract 25 squared. So we get 7,955.5, and that's what we're going to pop on our answer line. Question 25. Show that this algebraic fraction, adding this algebraic fraction, can simplify into that form where a and b are integers, and integers means whole numbers. So we're not wanting any messy decimals or anything like that. We want them to have whole numbers where the a and the b are. Okay, so we've got algebraic fractions. So yes, they look messy because they've got algebra, but we know how to add fractions. To add fractions, we need a common denominator. So what we're going to do, we're going to multiply this fraction, top and bottom, by x plus 2. So x plus 2 multiplied by x subtract 5. And then we're going to do the same on the bottom. X plus 2 is what we're multiplying, and then we've got the x subtract 2. So now for this fraction, we're going to multiply by x subtract 2. Top and bottom, remember, you've got to do the same to the top that you do to the bottom. So x subtract 2, x plus 5, and then x subtract 2 and x plus 2. It's really important to take care with this to make sure that you're writing the correct signs and you're not getting confused by all the different algebraic parts. So now we have the same denominator for both fractions, so we can write them as everything as on the numerators over that common denominator, which is x plus 2, x subtract 2. So now we're going to start expanding brackets to try and make our life a little bit easier. So when I expand these brackets, we're going to get x squared, subtract 5x, add 2x, subtract 10, plus x squared plus 5x, subtract 2x, subtract 10. And then on the bottom, x squared, subtract 2x, add 2x, subtract 4. So we're going to keep going. We're going to keep simplifying. So I'm going to simplify each of these sets of brackets that I expanded so I have less terms to deal with when I simplify and collect like terms later. So x squared, we have negative 5x plus 2x. So that's negative 3x, subtract 10, plus x squared. And then we've got 5x subtract 2x, which is positive 3x. And then we've got subtract 10. So that's simplified the top, so we're dealing with less terms. Let's do the bottom. So we have x squared, and then we have negative 2x, add 2x. So they cancel each other out. So that leaves us with x squared subtract 4 on the bottom, which is reassuring because that's what we're aiming for in this final form. Let's make the top a little bit nicer to deal with then. So we have x squared plus x squared. So we have 2x squareds. Then we have minus 3x, add 3x. Well, you're starting with negative 3 and you're adding 3x. So they're going to cancel each other out. So we don't have any x terms left on the top. But then we have negative 10, subtract 10. So we end up with negative 20 on the top. No more simplifying is available to us on that denominator. So now it looks similar to this form. Let's check if we can read off our values. So a is 2. That's an integer. That works for me. So a equals 2. B here, look, corresponds to the 20 there. That's a minus. This is a minus. So we're going to put b equals 20, not b equals negative 20, because the signs match there. So we've shown that these algebraic fractions simplify in this form to get integers for a and b of 2 and 20. Question 26. Here is a sketch of y equals x squared. So we've got that positive x squared curve. 26a, the minimum point of y equals x squared is at 0, 0. So this is 0, 0. Write down the coordinates of the minimum point of y equals x squared plus 2. So what we're looking at is the difference between these two equations. The difference here is that one's got plus 2 on the end. And because that plus 2 is not combined with the x within the squared term, it relates to the y coordinate. And what that means is this graph has shifted up 2 places on the y-axis. So currently we have x and y coordinates of 0 and 0. But if we're adding 2 to that y coordinate, it becomes 0, 2. 26b. The graph y equals x squared is reflected in the x-axis. Write down the equation of the graph after this transformation. So if this is the x-axis and we reflect this curve over it, we're going to end up with the curve looking like this, which is actually negative x squared. So the equation of the graph after this transformation would be y equals negative x squared. There's no other numbers or anything here because that point there is invariant. That point there will stay at 0, 0 whether we reflect over the x-axis or not. And then 26c, y equals x squared is now transformed to give y equals x plus 3 all squared. Describe fully this single transformation. So up here, this difference in the equation was not attached to the x and the squared term, so it dealt with the y coordinates. Here, this plus 3 is inside the brackets, it's inside the squared term, so this is dealing with the x coordinates, or what we do to move this graph sideways, so left or right. The y deals with up and down. And what we have to remember is when we're dealing with inside those brackets with that x coordinate, we're doing the opposite. So plus 3 doesn't mean go to the right 3 like transformations. It means do the opposite. So we're going to translate 3 units left, which would be a vector of -3, 0.